Today I am going to discuss about Rockwell hardness test. So we have several methods to find the hardness. Okay, the popular methods are Brenner hardness method, Rockwell hardness method, and Vickers hardness method. With the help of these three methods, we are going to find the hardness number. So depending on our requirement, we are going to prefer that kind of hardness operator. So here, Rockwell hardness tester, the range is 60 to 150 kg. According to this standard table, we are going to prefer what kind of indenter and we have to use to find the hardness, and also how much of load we need to apply on the particular material. We are going to find what is the hardness of the given specimens. This is the aim. So what the operators require to find the hardness means first we need to know what are the specimens we are having. So here we are having 5 specimens. One is stainless steel, second one is mild steel, this one is aluminium, and this one is brass, and this one is the copper. These 5 materials, what's the hardness we are going to find with the help of this operator. Here, this is the movable jaw. With the help of this lever, we can move the jaw upward direction as well as downward direction. Okay, these two are indenters. One is ball indenter, another one is diamond indenter. Okay, according to this table, standard table, okay, soft materials we are going to use ball indenter, hard materials we are going to use diamond indenter. With the help of this L&E, we are going to insert this. We are going to insert this indenter in this hinge, and with the help of this, we are going to tighten. Before going to do the experiment, we have to know what is hardness and what is the importance of hardness. So every material has some hardness and machinability, ductility, utility, like that, and a number of mechanical material properties it consists. If you don't know the hardness, you are not able to use as a cutting tool. If you have more hardness material, then easily we can cut the lesser hardness material with the help of more hardness material. Means here hardness is, what do you mean hardness means? It is one mechanical material property. So when we are applying a force on a material, its ability to resist the penetration of that load. That is called hardness. Okay. So what's the importance of this hardness is, if you don't know the hardness, we are not able to use as a cutting tool. Why? Because the cutting tool hardness is more than the specimen or workpiece. That's why we are going to know what's the hardness of particular cutting tool. Okay, what's the hardness of particular specimen or workpiece. If you know, then only we can use as a cutting tool for particular harder material. So that is the very importance of hardness. Okay. Now, I am going to, already I attached here diamond indenter. When I am going to use the stainless steel, so I am keeping the stainless steel here while moving downward the direction is jaw. So here you can also clearly we have some gap between the indenter and specimen. First we need to check the surface of the top line of the specimen. Where we don't have any indentation, already they use this specimen earlier. That's why we have some indentations. Where we don't have indentation, there we need to keep the position of the indenter. After that, we need to move this specimen upward direction while rotating of this. While rotating of this jaw upward direction. When I am rotating this lever in clockwise direction, see, you can observe this nail means the contact between the indenter and the specimen is starts. When I am applying the load continuously, the small scale indenter is moving, okay, toward leftward direction from 0 to 3. Why we need to apply load up to red mark means the exact indentation is happening in that particular zone. Means upper layer, see in the top layer we are having less cohesive forces, so that the indentation is easily, it can happen. So up to 3 point is up to 3 scale, if you apply load, it means that the cohesive force is resistive evenly in a particular specimen. Right. Now the indentation happen in the almost 2 to 3 layers from the top. So then we can expect the ability of resistance accuracy is more. Why we need to apply up to up to 3 scale means if you won't apply up to 3 indentations, if you apply the load on this, gradual load on this, what happened? Upper layers having less cohesive forces, so that the hardness value we may get some error. For that reason, we are applying the load up to 3. After that, we are going to apply gradual load. Okay. So, what we need to do is first we need to indent. Okay. After that, some resistance offered after some layers. Why? Because the cohesive forces of the grains are evenly distributed after some layers from the circumference. So, that's the reason we are applying initial load up to 3 scale in the small scale ready. After that, this is the stainless steel I am using here specimen. So we need to change here load, gradual apply load. So here 100 kg of this default it consists. So I am going to change 150. So this is 60 and this is 150. After applying this 150, okay, after changing this 150, this is the lever, okay, this is the unload direction, this is the loading direction, this direction is loading direction. So when I am applying the lever, you can just check the scale reading. So it moves from 20 to 30, means it rotates in anti-clockwise direction. It rotates in anti-clockwise direction. It means that some indentation due to this 150 kg AF, some indentation happened. With the help of that, how much of hardness value we can see here. Here we have 2 scales in the bigger scale reading. Okay, one is black color scale, another one is red color scale. So when we are using ball indenter, we should use that red color scale values. If you have a black indenter, if you have a diamond indenter, we should use the black scale. After completing our 3 readings, okay, we need to change the mild steel specimen. So instead of stainless steel, I am going to keep the mild steel specimen. Similarly, we have to apply the load. But before applying the load, we need to cross check what kind of indenter we have to use, okay, and how much of load we need to apply. According to this standard table, the stainless steel and mild steel having the same indenter, that is diamond indenter. So I am going to prefer diamond indenter, and according to this standard table, the mild steel also have to apply 150 kgf. So that I am going to straight away I am going to do the experiment without changing any indenter. After taking the 3 readings, the same procedure I am using, and after taking the 3 readings, I am going to change the indenter. Why? Because these 3 materials are soft materials. According to table, which kind of indenter means was the indenter we have to use, was the number of that indenter we need to cross check. When we are cross checking of this one, for aluminum alloys and soft materials, we have to use 1/16 inches ball indenter. So I am going to prefer this ball indenter. So with the help of this Allen key, I am going to change the indenter. And also I need to cross check how much of load we need to apply on the particular soft material when we are using indenter as 1/16 inches. So according to this table, we have to use 100 kgf on this soft materials. So while checking this indenter, similar procedure I am using for these 3 materials, soft materials. One is aluminium, copper and brass. So after changing of this 150 to 100, okay, so again we need to keep the specimen. The same procedure I am following. Up to 3 initial loading we need to do before applying gradual load. After getting the third point, means initial load, I am going to apply the gradual load on the specimen towards the reading. So when we are using ball indenter, okay, we need to check this reading in the dial gauge as red color reading only you need to perform. Okay, so initially after reaching the small scale, in a small scale that indenter is up to red mark, so you need to cross check what's the initial value on the red scale before applying the load. Okay, after that, after applying load, how many rotations will happen and what's the value of that particular hardness from this red scale we need to find. In this manner, similarly, we need to do 3 readings and we need to get the average. That average value represents the hardness of particular soft material. This is the method, this is the procedure we are going to use to find hardness value for different materials. Thank you.